Welcome to Kyvos training. In this session, you will learn how to register source data in Kyvos. We will cover these topics in this session. 1. Variety of data sources that Kyvos supports. 2. Adding folders. 3. Registering your data using SQL as input type. 4. Table-level properties. 5. Column-level properties. 6. Validating dataset. 7. Parameterizing source SQL. 8. Data profiling. And 9. Using other input types. Let us discuss the data sources supported by Kyvos. Kyvos' cloud-native architecture supports all major cloud data platforms such as AWS, GCP, Azure, and cloud data warehouses, including Snowflake, Redshift, and Google BigQuery. It also works with the latest releases of Cloudera and Apache Hadoop. You can register data files, tables, and SQLs from all these data sources. For this session, we will log in with the trainer's credentials. This user has designer access and custom rights to monitor Kyvos activities. After logging in, you will see the Kyvos homepage. From here, you can navigate to the Kyvos toolbar to create datasets or dataset folders. We recommend creating folders for better organization of your data. If you do not create a folder, your datasets will be created and maintained on the root folder. Now let's see how you can create a folder. Click the hamburger icon to expand or collapse the Kyvos toolbox. Select the Datasets option. Click the Actions menu and select Add Folder. Type the folder name. For example, I'm putting the name as Training Demo. Now click Add to create a new folder. You will see the folder added to the list. You can now use this folder to register your datasets and create a data source. Select the folder as the destination to register a new dataset. Kyvos supports advanced data types like maps, arrays, and structs and HCatalog tables. To register a dataset, you must first select a data connection from where the data will be fetched. If you do not see any connection, check with your Kyvos administrator. Now let us create a dataset in the folder that we created. Click the vertical ellipses. Select Add Dataset. Now select the connection that you want to use. For this session, I am using a Hadoop connection. From the input list, select the SQL option. Kyvos comes with a built-in intuitive SQL editor. Start typing in the SQL editor box. We are using the AdventureWorks dataset to demonstrate the use case. We have written a query as select star from AdventureWorks 2019 DIM customer. After typing the query, click Refresh. You can view the metadata of the registered table, which includes the number of columns and their names. To perform data transformations or select a dataset for processing Kyvos semantic models, you can modify the SQL and retrieve the columns as per your business requirement. In this case, we have applied a data transformation to get selected columns. You can view the list of available columns and mark this dataset as a dimension. To save the dataset, enter the dataset name as DIM customer and click Save. Let us learn about the table-level properties. In SQL, table-level properties are classified into dimension tables and fact tables. The current dataset is a dimension, as we have selected the dimension property. A dimension table contains attributes or characteristics that describe the data, such as customer names, product categories, or dates. A fact table contains the measure or numerical data for analysis, such as sales revenue, quantities sold, or expenses. Let us now create another dataset to create a fact dataset. Again, select the required connection. In this case, we're using a Hadoop connection. Select the input type as SQL. Type in your SQL statement and click Refresh. Now, mark the dataset as a fact. To save the dataset, enter the dataset name and click Save. I'm naming this as Fact Internet Sales. Marking table as a fact will help when creating relationships between tables. To create a new dataset using the table input type, click the Actions menu and select Add Dataset. Select the required connection. We are again using Hadoop connection. Select Table from the input type list and then select the database. Select the table name to proceed. Click Refresh. To use the file for lookup purposes, select the Lookup File checkbox. Specify it as a fact or dimension using the dimension or fact option. To save the dataset, enter the dataset name as Fact Inventory Table and click Save. Now let us look at the column level properties. We'll use the recently created DIM customer dataset to view the column level properties. Select a column on the right to view its properties. In the Column Properties section, you can view the selected column properties. The first option is to hide a column, which can be done by selecting the Hide Column checkbox. You can also specify a relationship key, such as a primary or foreign key. The primary key serves as a unique identifier for each record in a database table, while a foreign key refers to a field or set of fields in a database table that points to the primary key of another table. As this is a dimensional dataset, you can identify the key column and mark it as the primary key. And if you are using a fact dataset, you can identify the equivalent column customer key and mark it as a foreign key. You can change the column name in the field name section. Let's rename the customer key to Customer ID. Select the appropriate data type for each column. This ensures that the data is stored and processed correctly. Kyvos supports character data type, date data type, and numbered data type. If you have numeric data, you can choose a subdata type from the available options, such as double, long, float, or decimal. For integer values, select the long option. For the large decimal about 7 digits, select the float option. If you have a decimal number with high precision, select the double option. If the underlying data is numeric with precision and scale specifically defined to get the required accuracy, select the decimal option. You can specify the date format by selecting the date data type and specifying the format value. Then you can select the date format of the underlying data source to match in Kyvos. In this case, we are using the YYYY-MMDD format for both. Click Apply. You can also select the Incremental Identifier checkbox to avoid the complete processing of data. Set the format type. This is double, and you can specify the decimal places. Then specify the required actual value and click Apply. Not all data types can be formatted. You can preview your changes and filter the data to avoid unnecessary processing. Click Preview and verify the changes. You can also validate the data. To validate, click the Actions menu, the 3 dots, and select Validate. The Validate action verifies the underlying data for correctness. In case of an error, you will see warnings in red. If the dataset is valid, you will see the dataset is valid notification on the Kyvos UI. You must ensure your dataset is valid. Now that you have learned how to create a dataset, let us discuss about the parameterized source SQL. In this topic, we will discuss using dataset parameters to update the dataset definition when calling a semantic model process using REST or Java APIs. We will also focus on the areas allowed to be parameterized in the datasets, such as filter values, database name, schema name, table name, the file path for a file-based dataset, and a part of SQL query in SQL-based dataset. You can pass the parameters for a dataset in APIs for semantic model process, test, full data process, incremental data process, and process profiling jobs. These can be executed on the semantic model on the dataset. If any parameter is present in the dataset, Kyvos will use the default value from the dataset definition. However, this default value will not be visible through REST or Java APIs. If a semantic model is designed over multiple datasets, each dataset with the same parameter name, the parameter value will get replaced in each source SQL statement before its execution. To define parameters, click the Actions menu, the 3 dots, and select Parameters. On the Parameters dialog, type the parameter name, say P1. Enter a parameter description. This is optional. Enter a parameter value. The parameter's default value will be used if the value of the given parameter is not present in the semantic model process in REST API. The value will be used in other dataset operations, such as preview, validation, save, and so on. Now, click Apply, and then click Save. Note that multiple parameters in the same dataset cannot have the same names. Click the Filter Data link displayed in blue on the right of the UI. The filter dialog is displayed. You can use the parameters in the Filter Data option. In the filter list, select the customer key on which you have created the parameters. Select the criteria that is not equal to or is equal to from the list. Select the parameter and then provide its values. All the parameters you have defined will get listed here. Click Apply. And while processing the semantic model, these filters will get respected. It will filter out the records based on the filter criteria you have provided. Now, let us discuss data profiling. In this topic, we will discuss data profile and how this helps in designing the semantic model. Once you complete all the dataset changes, you can profile the data. A data profile is a type of analysis that involves examining a sample of data. This analysis can help you design a more responsive semantic model and dataset by identifying important fields and understanding how they relate to one another. This allows you to create a more efficient dataset optimized for semantic model processing, queries, and analysis. The data profile recommends which advanced properties and process options you can use. Note that not all object types support a data profile. However, if your object type does support it, you can use it to gain valuable insights into your data and design a more responsive dataset. For data profiling, you need to ensure the following. By default, it runs on the column level looking for distinct value counts, value distribution, is the data skewed, cardinality, and seeks invalid value counts. You can view details about the data including field names, field types, distinct value counts, and value distribution. For numeric fields, you'll see the minimum and maximum values and the number of invalid values. You can also scroll to a column, view a summary, download data profile logs, or export the profile result. Additionally, you can change the default profile selection details. Let us see how you can create a data profile. From the Toolbox area, click the Actions menu, and then click Add Other Jobs. Choose Data Profile. If required, you can change the default profile selection. Choose which records to use, all records for complete analysis, or use a random sample. Now, schedule when to run the profile. Typically, you will run a profile only a few times, so you may want to start with now or once. Click Schedule when finished. It starts executing jobs that you can view through View Job Histories. As you can see, the data profile job is running. Once it is completed, it will provide you with insights into the data. You can also double-click to view the details of the data profile job. You can view the job summary once the data profile job is completed. As you can see, the status of the data profile is shown as Success. You can also view data profile results. To view results, click the Actions menu, select Last Profile Result. On this screen, you can analyze the data. Now let us discuss other input types that you can use to create datasets. You can register a dataset for use with Kyvos using other input types, such as HDFS and Table. Now we'll walk you through the steps to register a dataset using HDFS. Select the input type as HDFS. Select the file. Click the Actions menu to navigate to the data file. Now we select the AdventureWorks file and click Select. Specify the file type, such as character-separated values, Parquet, or sequence. Click the File Properties link to specify properties. Provide the line separator, field separator, escape characters, enclosed by, skip top lines, and encoding type options according to your file type. From the compression list, Select the compression format of the data file as None or LZO. If the data includes header information, select Contains Header Row so that the column headings will not be included as part of the data. Select Ignore Empty Rows to have empty rows ignored. Select Key as Column to set the field name to be the column description. Select if you want to list the data row key as a data column. This is applicable for sequence files only. The key column will be the first column. Select File Name as Column to add the source file path as a column. Click Apply. Click Refresh to view the column on the right side. Now, we'll walk you through the steps to register a dataset using the table. Now, select the connection that you want to use. Here, I am again using a Hadoop connection. From the input list, select the Table option. Select the table database followed by a table, or enter a term into the search box to quickly navigate to the table. Select the table. Now, we are selecting DIM Customer. To use the file for lookup purposes, select the Lookup File checkbox. Click Refresh to view the column on the right side. Specify whether the dataset is a dimension or fact. If the source data contains a primary or foreign key, the system automatically marks it. If not, you must mark it as a primary or foreign key. When you view the column list, you can sort, filter, and set column properties as needed. Sorting is based on ascending and descending names. You can filter data using the following options. Data types, such as character, number, and date. Data subtype, double, long, float, and decimal. Visibility means hidden columns will be sorted as after the visible columns. Let's select the character data types. This will show you all the character data type columns. After the changes, you can revert. Again, you can use the column properties like we have learned earlier in this session. Similarly, you can also use filter data as seen earlier. Click Save. To save the dataset, enter the dataset name as Customer Table, then click Save. You can also revert the changes using the Revert option. This marks the end of our session on how to create datasets or folders with Kyvos from a data source using various input types. In the next video, we will cover how to create a relationship schema in Kyvos using these registered datasets. Thank you.